All right, let's go into this example now. We're going to go ahead and find all the solutions of sine of x plus square root of 2 equals negative sine of x in the interval from 0 to 2 pi. And this one's slightly different in that when we represent our answers, we only need to find the answers now between 0 and 2 pi, which means we don't need to tack on that 2 pi n where n is within that strange looking z, right? We don't have to do all that because we only want the answers represented within one rotation around the unit circle, right? So that's going to be a little helpful there. All right, and so you can tell by the title here that the way that you're going to solve this is by collecting like terms. And so as you can see here, sine of x and negative sine of x are common terms. So what I'm going to do first is I'm going to go ahead and add sine x to both sides. Okay, so I'm going to do this. I'm going to add sine of x and add sine of x, which now gives us a 2 sine of x. And then simultaneously, I'm going to go to move my radical 2 to the right side. That's negative radical 2. All right, and if I'm going to solve for sine of x, I'm going to divide by 2. And I get sine of x equals negative radical 2 over 2. That's not too bad, right? All right, so now we got to think of our unit circle now. All right, let me go right here. Well, the only places where sine is negative, again, we're looking at the y values, right? See, this is positive, so it's going to be in the third and fourth quadrant. And that's going to be the one that's right in the middle, right? So that's the, let's see, 1, 2, 3, 4, that's 5 pi over 4. So one of them is going to be x equals 5 pi over 4. And let's see here. And that means if you just add pi to that, right over here, right, this is 5, 6, 7, so that's 7 pi over 4. So 7 pi over 4. So those two values would give you negative radical 2 over 2. And that's going to be it there. We don't need to put plus 2 pi n because of this. It only wants the answers from 0 to 2 pi.